Hello and welcome to the Thursday, April 4th, 2024 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and I'm recording from Jacksonville, Florida. Today I played a little bit with Anthony Weams' backdoor implementation xzbot. It implements the xzutils backdoor, and then xzbot is also a tool that essentially simulates a tool that an attacker would use in order to connect to a backdoored system. Now, one of the tricky parts here, of course, is that we don't have the key material that the attacker would have used to connect to the original backdoor. So the genius here of Anthony's implementation is that, well, you can just bring your own key and with that just experiment how the backdoor would work. I took a quick stab at it and I didn't actually implement the backdoor part. I really just wanted to see what happens if I use this client to connect to an SSH server that's, well, running perfectly fine, that does not have the backdoor installed. In my experiments, there was one specific error message that showed up, an error in libcrypto. I did use a standard Ubuntu 22 install. May not have used the client quite correctly. If anybody has any insight, any other experience with this client, let me know. Or if you saw any other error messages, that would also be kind of helpful. I also used to connect a username that was actually not allowed to connect a root in this case, which is the default user in Anthony's implementation. As far as the network traffic goes, I didn't really see anything great here to pick up on or to use as a signature, other than the fact that you have relatively sort of short-lived sessions. Remember, the attacker isn't actually logging in. They're just sending the commands as part of the SSH handshake with their key, and these commands are then executed by the backdoored SSH server. And Google came forward with a new standard that they hope will replace or at least supplement regular sessions that we're using to retain an authenticated connection with a particular web application. The problem with the existing system of simple session cookies is that, well, it's static. If an attacker steals a session cookie, and we have often seen this happen in the past, the attacker essentially becomes the user, and there are no great solutions in existing browsers to make sure these cookies are not stolen. The solution that Google is attempting to implement here is to link the sessions to a particular device. They're calling them device-bound session credentials, or DBSC. This happens via the cryptographic storage that pretty much all systems are supporting these days in some form, some kind of keychain, TPM, or other devices that are often implemented these days in systems and operating systems. So the way this will work is whenever a website would like to establish a session with your system, a public-private key pair is being created. The private key is never sent over the wire, as it should be, and is saved in the secure storage on the device. The server can then provide challenges that are digitally signed by the client in order to prove that the server is still talking to the same client. This also takes care of some of the privacy issues around cookies. One of the problems, of course, is tracking users across multiple sites. To prevent this, the browser will create unique key pairs for every website it connects to, and these key pairs, of course, can then also be rotated occasionally. You'll see this show up as an optional feature initially in Google Chrome, but Google plans to make this an open standard and hopes that other browsers, identity providers, and the like will also leverage this technology. And then we got 4 more vulnerabilities in Ivanti Connect Secure. Highest CVSS score is 8.2 for 2 of the vulnerabilities. One of the vulnerabilities is a heap overflow in the IPsec component, and it could lead to arbitrary code execution. as Ivanti states it, in certain conditions. They don't really specify what these conditions are. Authentication is not required for any of these vulnerabilities, and patches are available. And Google released updates for its Pixel phones. 2 of the vulnerabilities being patched here are already being exploited in the wild. One is a privilege escalation vulnerability, and the second one an information disclosure vulnerability. Again, this only affects Google Pixel phones, not necessarily other Android devices. And remember, well, by the time you listen to this, it's probably today for you on Thursday at 10 a.m. Eastern. We do have a special edition of the Wait Justin InfoSec podcast with Boyan, and he'll walk us through some of the reverse engineering he did on the xzbot backdoor. Well, that's it, and thanks for listening, and talk to you again tomorrow. Bye.